Alrighty, good afternoon, everybody. We've made it to session 2, which is Common Ports and Services. And the reason that we included this in our boot camp was that in a lot of cases, it's important to know how some of the tools, or at least some of the software or the services that are going to be running within your environment. It's important to know both how they work and where they're configured. In the past, whenever we've done any sort of competition, a lot of the times what will end up happening is either the red team has made some misconfigurations in those files to a point where they're insecure by default, and there's some sort of attack vector that they can sneak onto the system with or at some point during the day, if they get in some other method, or they maybe have some sort of scheduled task or a cron job, and they're going to go ahead and modify those files during the competition. And so most cases that simply just either makes it where they no longer function, or similarly to the first option where it maybe creates some sort of backdoor for them in order to get ready to go. So we've selected, the title here is only SSH, HTTP, and DNS. We're actually also going to cover FTP as well today. And those are all the different types of services that are going to be used during, let's say, the NCAE cyber games. To some extent, they're used in the collegiate cyber defense competition, although they add on quite a bit of extra stuff with a database server, and then they also have an Active Directory in there that is doing some authentication with it's not, I don't remember if it's authentication, but it's interconnected with their email server within the environment. So hopefully, at least in terms of kind of working through this stuff, you get an idea of kind of what you need to do. As part of the NCAE cyber games, one of the important things that they actually test you on is actually turning these things on and configuring them to work with the competition requirements. So for instance, we're not going to do it today, but within HTTPS, during the competition, we'll be asked to import an SSL certificate and get that HTTPS service running. So there's a few different ways in which that's important. Setting up DNS is one of the things that always takes a very long time as part of that competition. We're going to use some of the default files that upon installation we get, but during the live competition, typically they'll make those practically unusable. And if you're trying to edit them in real time, it doesn't work. But we are going to use those today just to give us a form and a guide. But the file is going to look fairly similar if you were to create it live during the competition. In terms of where we're at so far, so on Monday, we went through how to learn how to access the environment. I'll very briefly kind of show that today as I'm logging into the system. We talked a little bit, or quite a bit, about the command line. I showed you Bandit over the wire as a good tool that you can use to learn how to use the command line if that's the first time that you've ever used it. On Tuesday, we took a look at computer networking. So we went ahead and we talked about IPv4. We took a look at subnetting. I showed off the network that we're going to be constructing. And then we went ahead and we did it. We went ahead and we assigned some static IP addresses to a few different machines within our environment. We looked at what are some of the differences between how different Linux distributions may handle that. Each of them, there's different options, of course. When we looked at CentOS, there we had the IFCFG ETH0 or ETH1 file, but we could also use, I believe it was called NMTUI. So there were a few different options for each of them. We looked at those and we went ahead and set up our network. I did notice, and someone did shoot me an email after the session, was the network diagram that I had in last lecture was actually incorrect. It was an older version. Initially, when we were designing everything, we wanted to have it where the students were going to be kind of setting it up similar to that competition, where each team has an identifier, and that identifier is used in some way as part of the IP infrastructure. For this boot camp, what we ended up doing was we said, well, we don't want to make it too confusing. So everyone is just they have their own internal network here. It's on their own interface within the environment. And so we're okay with just creating our own. Everybody's going to have the same IP addresses. And so that's why when we looked at that figure, it looks different than what we were actually doing on Tuesday. So I just wanted to make that known. Just kind of an announcement. I haven't quite updated in the Google Drive, and I'll post a link in the Zoom chat when we reach the break. If people haven't seen that that Google Drive yet, that's going to have all the session slides that I have here. But that is going to be included as a link in the YouTube video in the description. So I haven't quite updated those lecture slides yet, but at least very least I've made that kind of known. I also made a pinned comment and made an announcement on Discord. So I just wanted to make that quick little correction there. On Wednesday, I believe it's Wednesday next week, we're going to be looking at the red team's perspective. At the end of today's session, I'm going to talk briefly about the TryHackMe platform, which we're going to go ahead and use for next session. They have a whole bunch of wonderful guided walkthroughs on different tools, techniques, and strategies as part of both red teaming. They've been doing a lot better job recently of adding an additional blue teaming and incident response topics as well. So they've definitely been expanding that platform, but we're going to go ahead and introduce that platform. It's a wonderful resource. If you have never used that platform before, it's a great resource to get yourself started in cybersecurity. So I wanted to make sure that was integrated in some way. And it does kind of help because we don't have to then have a whole bunch of different vulnerable setups, and we don't have to create those necessarily on our end. So we can go ahead and use those. On, I believe, Thursday next week, we're going to be doing an introduction to firewalls. So we're going to be taking a look at both from a network firewall point of view and then also a host-based firewall. So we're going to take a look at those two perspectives, and then we'll move on to hardening and incident response. So I just wanted to kind of give us a refresher on kind of where we're at and where things are headed. All right. So I'll go ahead and I'm going to go ahead and spin up the environment. So, and again, we have currently everybody is in either one of two blocks. You're either as part of block A or block B. In this case, we don't have our own SSL or TLS certificate. So unfortunately, it is self-signed for the moment. But oh, I don't want to use root. I'm going to use Darwin3. So we'll go ahead and log in. At least in terms of the machines that we're going to be using today, you're going to want to have the following machines on. So you're going to want to have your router on, because that's going to allow you to have access to the internet so that you can download and install all of the different tools that we have. I'd also recommend installing the Kali Linux machine. That's going to give you at least a GUI-based interface there, rather than just having to work with the command line all day when we're testing and making sure that whatever we set up works fine. We're going to set up all three, the website, the workstation, and the DNS. So you're going to want to go ahead and turn those on. And so while I kind of give a brief overview in terms of kind of what are different ports, how does two protocols, UDP and TCP, how do generally those work, I kind of wanted to put those in there so that you can have an opportunity, if you have not yet turned these on, to go ahead and turn these on and let them actually get started. Because what we've found in the past is that if a large number of students go ahead and turn everything on at the same time, things slow down pretty dramatically. So just kind of wanted to make that, give you guys time to get that to you. All right. So before we get into it, I'm briefly going to talk about TCP, UDP, and then the three-way handshake. So we have first the UDP, which is the user data protocol. And these are both ways in which most of these services are then going to be communicating with our clients. So in most cases, you have some sort of service on a server and a client, and mostly they're going to be communicating with one of these two protocols. What UDP does is it's a connectionless protocol. And so essentially what that means is that either the servant or the client, or in most cases, if they're making a request, you'll make a request and then you hope that you'll get a reply back. They're just going to send the data. When we look at the TCP, what's going to happen is that there's going to be some form of a handshake that they're going to make sure that that connection is established, that they're not losing information as it's going along, and that everything is in the proper order when it's being reconstructed. And so with UDP, what ends up happening, and we kind of see this here in this beam that we have, where we've got these two guys, and one of them says, second packet sent. And the first guy goes, well, where's the first one? He's like, and then he says, fifth packet sent. And so there's no insurance that it's actually making it there to the destination. So you're not resending the packet if it's been too long. There's a few different use cases that we might want to take a look at for that. So for instance, with video streaming or voice over IP, obviously with those ones, there's a lot of data that you need. Videos have a lot of information and data in them, and you want to watch it at a pretty steady resolution or a steady output most of the time. And so what ends up happening is you'll see like kind of that either those little patches sometimes back in the olden days when internet was a little bit less reliable or was not as fast. You'd have little patches on the screen because not all the packets had made it. An additional note, so when we take a look at things with from the red teaming perspective, is that it's difficult to scan UDP ports because sometimes they don't necessarily always just respond. And so it's often difficult because you're not setting up that connection. It's difficult to know, did the packets get lost or is there something being filtered on the server end? And so that's kind of why that could be a little bit difficult to scan. It takes a lot longer to scan those UDP ports. But the good news is those are less used when we talk about things that we may try and attack a machine. Then we get to TCP, or the transmission control protocol. That one is a connection-oriented protocol, and it uses the three-way handshake. So I'll show a diagram of kind of how that functions. But it ensures that there's communication and that connection is established. And so in the event that a packet gets lost, it will go ahead and resend it, and it'll know to resend it. There are a few different use cases here. So we have file transfer protocol. I don't know why I put TCP there. It should be FTP. Then we have simple mail transfer protocol, and then hypertext transfer protocol, or HTTP. Here's just a general, sometimes some people find it interesting to see just kind of the different sizes of it, the different parts of the packets. So these are the different headers. So UDP clearly has a much smaller packet. There's less that needs to be kind of maintained there. It's just, okay, who sent it? Where is it supposed to go? And that's really it. How long is it? And then on the TCP side, you've got additional information. You have the sequence number, what packet number am I in the chain? And then we have a whole bunch of different other options as well. So there's different things that you can use. But at the very least, these are the two that at least that's how their packet headers look, and kind of the differences between them. In terms of how the three-way handshake works, and we're going to actually come back around to this next week when we're taking a look at Nmap and how different what are known as stealth scans may operate, and why they're not always necessarily that stealthy. But in terms of how they function, and most of the times it comes back to this three-way handshake. So whenever you're communicating with the server, what's going to end up happening is you're going to go ahead and contact it with a SYN request. Then the server will respond with a SYN-ACK saying, okay, yes, I've received. Please acknowledge that you want to complete this connection. And then you confirm that you want to communicate with that server. You're ready to go. And then communication continues. At least in terms of, as I mentioned with Nmap, and we'll take a look at this next week a little bit more in depth, is that with different Nmap scans, you may just send a SYN, and then the server will wait. And then it'll just, after a certain time, that'll time out, and it'll just forget that somebody had passed that message to it. And the reason that oftentimes we just kind of throw that out is, I mean, there's just an innumerable number of machines out there in the wild. And so you could be getting traffic. And so just recording all of those SYNs could take up a lot of information. So that's sometimes why we consider that a stealth one, because in many protocols, they don't actually record when a SYN was sent. They only record when the connection was confirmed. So that's just as a little bit of information. Some important TCP points. So we have 21, which we're going to take a look at today, which is the file transfer protocol. We're going to use that to transfer files. In terms of a cyber competition, the reason that they like to use that one is that in a lot of cases, you're not protecting that to the point where you've limited the certain users that are only allowed to use it. You're not using, we're going to look at chroot today. And so you're able to maneuver and you're able to go anywhere else in the file system that you may want to. And so that could be an issue. Next we have, and then additionally, a lot of times it also communicates in plain text. So there's no encryption that's going on there. And so if I, for instance, had Wireshark on the machine, I could go ahead and I could actually monitor any uploading or downloading that took place, and I can actually recover that file. Next, I have SSH, which is secure shell. It's on port 22, and it's used as a secure connection to the remote computer. And the insecure version is actually Telnet. We don't use Telnet anymore for good reason, because it was in plain text. But we use secure shell. We'll show installing that and using that today. A lot of the times you may use that for remote management and operation. So let's say that you have a server out there, and rather than just having a direct terminal that you're going to be typing in and doing things with, you're just going to remote into it. And so that's why you may use SSH. Then we have SMTP, which is the simple mail transfer protocol. That's just going to send mail. In competitions like the CyberForce competition and CCDC, they do have those types of servers in there. Next, we have HTTP, which is we're not gonna make it super fancy. It's gonna be probably just the index.html or the homepage on the website. But we're gonna set up a very basic HTTP server. We're gonna get more into that next week, or probably more actually, the more likely the week after that, when we're taking a look at incident response in terms of how could we monitor that. But we're gonna set up a very basic web server. Then we have POP3, which kind of similar to SMTP, it's going to retrieve the emails. And then finally, we have 445, which is SMB, which is secure message block. You'll primarily find these in Windows environments. So it's, I guess, I kind of think of it sometimes as kind of the Windows analog to FTP, although you do see FTP servers in Windows as well. On the flip side, we have UDP ports. The biggest one is going to be DNS. It's going to be for domain names. We'll talk a little bit about how those work, at least in terms of when you think of it, whenever you type in, let's say, google.com, you don't actually know the IP address for Google. You're relying on DNS to go ahead and resolve that for you and give you the IP address so that you can then go ahead and view the website for you. Technically, it can fall back on TCP if DNS is unavailable, or if the UDP is unavailable. And then lastly, we have DHCP. So we didn't go into setting up our own DHCP server. We're kind of relying on our own infrastructure for that DHCP. But at least in terms of assigning IP addresses dynamically and automatically within your network, DHCP is going to rely on UDP. So those are all our ports, or at least all our services that necessarily at least from a beginner standpoint, we're going to be working through and talking through. There's a lot more that we could do. For instance, we could look at setting up a mail server, and that's going to be a little bit more involved. We could do SMB. We could do more with, let's say, an Active Directory, but at least since this is primarily aimed at our beginners, we went ahead and we just did these ones. So we're going to go ahead and tempt fate, and we're going to go ahead and see if we can set all of these different services up within our own sandboxes live. Kind of hopefully fight against the curse of doing things live. Unfortunately, so if you are joining us, if this is your first time joining us and you have not followed along to our networking, this is going to be a little bit tricky to follow along with if you are planning on following along, because you do need internet connection for the 3 internal machines. So just be aware of that. Unfortunately, I'm not going to quickly go through, because it would take a little bit of time to quickly go through and show you folks resetting that up. So I apologize for that. So for now, just take notes or kind of watch along if you haven't yet set up the network internally within your suite. So first, we're going to start with the Ubuntu workstation. So there we go. We're actually first going to start out with the Ubuntu workstation, and this actually still shows me my my net plan configuration file for setting up my internet connection. I'm going to go ahead and clear off the screen. I'm going to verify that I have an IP address. Okay. So at least in terms of the workstation, we are on 192.168.0.3. And one thing that we can also do, and I'm going to also highlight it, is we can use the netstat command. I don't actually remember if that's installed on here. It should be. We're going to use netstat ANT and actually ANT LPU. And you can actually kind of move that around. Other people have different ways in which they write out that flag. So you could say netstat-TNPLU, and it'll come out the same way. What netstat allows us to do is it allows us to monitor what active ports and active listeners that we have on this machine. So in this case, all we have right now is a loop back to 53. And in most cases, that's just actually just trying to get back to itself with DNS. But we don't have anything else installed on this. Let me see. I think the only other machine that actually default installs stuff is actually the set machines. They actually install quite a few things by default. So if we go ahead and check that out, and actually, I don't think this actually comes with netstat. Let's see. So we can check. It may actually use SS. Yeah, SS? Yes. Okay. So it has SS instead of netstat. I believe It has the same. Yeah, it actually has the same. I don't use SS as much. That's technically the newer one. But as you can see here with the website that we're going to be doing, it already has port 22, which is SSH, and port 25, which is a web server, which is a really, to me, is a really weird thing to automatically install. But it goes ahead and installs a simple mail server. Not entirely sure why they decided that with CentOS, but they went ahead and did it. But anyway, going back to our Ubuntu workstation, we're going to go ahead and start using our package manager here. So for Ubuntu, most of the time, you're going to be using a tool called apt. And it also, you can also say apt-get. I don't know exactly what the differences are, but if I say apt install, in this case, we're going to start off with SSH. It's going to go ahead and give you a list of everything that it's going to go ahead and either install due to the dependencies or update. And we're going to go ahead and type a yes in there. And it's going to go ahead and fetch those files, download them for us, and it's going to go ahead and install all that for us. I don't remember what the flag is, but I believe you're able to indicate what version that you want. But I don't remember what flag off the top of my head that you may want to use in order to get that. So as you can see here, it's already done. If I were to run, let's say, apt-get install instead, it's going to just kind of respond back to be okay. It's already done. If you're doing, you can get the updated versions of your software, I believe, with apt update. So if I say apt update, it's going to go ahead and that doesn't install it yet. All it does is it just goes ahead and it looks at the different archive repositories for these packages. And it just says, okay, this is what we need. I don't remember if it directly downloads it yet, but at least it tells you what needs to be updated. And you can say apt upgrade to update those packages. In some cases, you would then need to reboot the system. So just be aware of that. Is running an apt update and then an apt upgrade does not necessarily always enforce that upgraded package. Sometimes you have to restart the computer to get that. So we've gone ahead and we've installed SSH. So relatively easy. We're already technically it should be on. So if I check out my netstat command again, netstat and actually did I spell that right? Yeah, and tlpu. As I fight against that. And as we can see here, in this case, it went ahead and this line here, I'm actually going to pull out my highlighter, not my highlighter, but my laser pointer, is this, I believe, was probably some sort of something left over from when I was downloading stuff, most likely. But as we can see here, we see 22. We see both, I guess, yeah, here we see 22. And so we know that 22, which is SSH, is listening on the machine. We can verify that it was installed or is that it's on by using systemctl. So if I say systemctl status SSH, it's going to go ahead and tell me. In this case, when I installed SSH, it went ahead and installed an OpenBSD version of SSH. So we see it's running. If you make a mistake with the configuration file, and we'll see this in a minute, journalctl. How would you scale? Oh, yes. At least in terms, apologies for that. And let me know if the new version is better. Is that better? Sorry about that. Thank you for the comment there. Is that a better size for the window? Yes. Okay. Sorry about that. I guess to show some of the commands that I've been running, the first one is netstat, ANTLPU. It shows me the different connections and listening status, listening ports. I'm still not able to install. Okay, most likely, are you able to can you ping google.com? And are you able to get a response? And we'll take a look at this, depending on kind of how long this troubleshooting gets, kind of depending on kind of how long these questions go. But I will take a look at it when we reach the break, if we're not able to look at it right away. You're able to ping, okay, and then did you try, okay, that's weird. And then did you do apt, and you did apt install SSH, and then, okay. So during the break, I will work with you on figuring out exactly what that issue is, because if you're able to ping google.com, you're able to access the internet. So I'm not entirely sure what the issue is. Let me check something else real quick here. Oh, that's not what I wanted. So I will double check another setup real quick here. Give me one moment, everybody. Okay, so we will look at that again. Okay. Okay, so we'll take a look at that in the break, and I'll be sure to come back around to that. I apologize for that. Alrighty, so again, we're back here with SSH. So again, we could take a look at systemctl. So I guess, yeah, apt install SSH. We can take a look at to make sure that it's running with systemctl status SSH, and it is running. If you want to go ahead and actually, real quick, I will show you kind of how to connect to it. So if I jump over to the Kali Linux machine, I'll do the same thing here. I'll make this bigger. If you are in block A, your login is either root and tor or Kali and Kali, all lowercase. And if you're in block B, it is root and tor. And in order to access this, actually, so I'm going to go ahead and make sure I can reach my other machine. So in this case, 192.168.0.3. And we see that the ping is coming through. So we know that we can reach it. And I'm going to go ahead and SSH administrator at 192.168.0.3. It's going to go ahead and it's going to ask you to make sure that you're okay with that key. If I was doing this a little bit more properly, is I would go ahead and make sure that the key fingerprint of that host does match this. I want to always make sure that I am actually connecting to the machine that I need to. Let's say that if someone set up some sort of I don't know, man in the middle wouldn't be the word there, because they could just pretend to be it. But if somebody set up another server in your environment and somehow managed to get that IP address and was logging all of the input attempts, they could potentially get that credential there. So in this case, we're just going to go ahead and accept it. And in this case, the password is ABC123. And that actually may have an exclamation point at the end there. Sec. Oh, no, it was just ABC, and to show you in plain text, it's ABC. So as you can see here, I am logged in. We see some information and statistics on the Ubuntu machine. And then we also see that, hey, we are the administrator on Ubuntu work. I can, of course, do anything that I want on here. If I wanted, I could do a sudo su and jump up to root and then do whatever I wanted here. For now, I'm actually going to go ahead and I'm actually going to very briefly create another user to show a few other things with our configuration files. So if I go ahead and I add user, we're going to go ahead and just create a new user called David. In this case, I'm going to also keep David's password as ABC123. We're just going to default everything here. And if I go ahead and I double check his home directory, we see that there is a new user. I apologize for the font here is kind of bad, but or not the font, the color here is kind of bad. But I can go ahead and head into David's, or I could switch user over to David. So now I'm David. I'm a new user on the machine. Whenever we went ahead and created this new user, similarly, I can SSH as David into 192.168.0. So if I go ahead and enter David's password, we're able to log in and we're able to move around and we're able to do whatever we need. So that's just a very brief, that's SSH in a nutshell for you. I was kind of debating how much we wanted to go with that. So what we're actually going to go ahead and do is we're actually going to go ahead and work inside the etc SSH, and we're actually going to turn off the password authentication and just use an SSH key in order to authenticate. And the reason that you would use an SSH key is that if I just have the server open, anybody could anybody could go ahead and attempt to log in on that machine with the username and password. And it's unlikely, as long as you're using a strong password, that they'll be able to necessarily brute force it, but they could just keep trying. They could maybe spoof their IP address repeatedly and just kind of keep trying down the line. And eventually in theory, given enough time and enough resources, they would be able to brute force it. But if we go ahead and use an SSH key, we can go ahead and just ensure that only machines that we have given specific authorization with that key are able to go ahead and log in. And the way that works is I have a quick visual here. Is let's say that I have a server that I'm trying to log into. I'm going to go ahead and generate a private and public key on my client. And this generally, I believe, is going to be the private and public key that you're going to use from here on out. You're going to have some way, and this is very important, you're going to have some way to securely move that public key over. I believe SSH actually has a utility to do that. For some reason, none of these machines have it installed on there by default. But you do need to have permission to actually access this machine. You're going to go ahead and move over your public key, and then you'll be able to log in. Now, the risk here is if your private key gets stolen. If your private key gets stolen, anybody could then impersonate you and log in. So that's just as a note there. So before we do that, let's go ahead and take a look at etc SSH, SSHD config, and we'll kind of see what we can work with and how we can go ahead and implement that with our configuration file. So if I go ahead and jump back over, go ahead and clear. I'm going to use nano here. And I'm actually going to exit back out to root. Again, as you go over time, we're using root here to just make it faster and more streamlined. But you are going to want to slowly make your way and work in an administrator mode. So using sudo or not sudo, and then slowly using sudo as little as you can. So that's just as a note there. But we're going to go ahead and jump into etc SSH, SSHD underscore config. So there we go. And we can do quite a few things here. So for instance, one of the things that we can do is we can go ahead and we can change the port that we're listening on. So let's say we don't want to listen to port on port 22 anymore. Maybe we want to say like port 1234. So I'll quickly show that. So let's say that I want to listen on 1234 instead. I'm going to go ahead and write that out. And in order for that change to take effect, we actually have to reboot SSH. So systemctl restart SSH. We'll go ahead and do that. We didn't get any errors, but if I go ahead and run an netstat, we go ahead and see that rather than being on port 22, and there is actually, we're still connected on that. I don't know. Let's see if it actually kicked me out. It did not kick me out. That's surprising, seeing as I restarted the service. But we still have that old connection. But at the very least, SSH is now listening on port 1234. That's something that you can do. I don't recommend doing that. Not that there's nothing technically wrong with that. Some people tend to think that we've moved it off of the common default port. So yes, there are some tools and things that just will default to trying to either brute force or just try all SSH servers out there on the internet on port 22. But anybody who actually is knowing what they're doing, they would use something like Nmap, and Nmap would identify that you have that SSH server on port 1234. So yes, it would kind of limit, I guess it does limit the potential for certain automated tools that are just looking for port 22. But typically, actually, if you're working against, if somebody's trying to actually do something against that, it doesn't really necessarily add anything to that security. So I'm going to go ahead and jump back into that. So we're actually going to change it back to port 22. There we go. So we're listening on port 22. We can give the IP address if we wanted to. The reason that you would do that is, let's say that we have something like our network diagram, and we have the setup where we've got that router and it's listening on two different ether interfaces. And let's say that we only want it to listen onto one of those interfaces. We don't want it to listen to another one. That may be one of the ones that you may want to do there. And here we're going to go ahead and here we see there's a few different things. So for instance, we could set the number of tries that people attempt to do. We see the number of sessions that you can have at the same time. And here we see pub key authentication. So this is one thing that we want to go ahead and do. So we want to go ahead and set up our SSH keys. So we're going to go ahead and uncomment that. So we'll say pub key authentication, yes. We can, if we want to, say authorize keys files. I'll show you in a minute how we're going to go ahead and do this. But this is essentially the location where we're going to go ahead and say, hey, here are the keys that we can use. And let's see, is there anything else that we want to do? We can, if we wanted to, we could, and actually in this case, we're going to change password authentication. So in this case, we don't want people to be able to log in with a password. So in this case, we're going to say no. If you are really going crazy, you don't need to uncomment this. But if you really wanted to, I don't know why you'd ever want to, you could, in theory, change this to yes. But by default, it defaults to no to empty passwords. And I don't remember, I want to say that um, I want to say that it is automatically denied to log in via root. So that's one thing there. I don't think you're allowed to log in remotely via root. So that's what we've gone ahead and done. We've gone ahead and added in pub key authentication. If yes, you can add this authorized key file. I believe it automatically defaults to SSH/authorized keys, but we're good there for now. And there's a few other things that we could do here. So the only changes that we made are pub key authentication, authorized keys file, and then I went ahead and set password authentication to no. So we're going to go ahead and write that out, and we're going to go ahead and exit. I'm going to say systemctl restart SSH, and we didn't get any errors, so we can go ahead and assume that it's running. And let's head back out to my server. So if I go ahead and SSH as David again, it's not even going to ask me for a password. It's just going to say, okay, permission denied. And the reason that it's going to give for that is it needs a public key. If I was to try with administrator, oops, it's going to go ahead and tell me denied. And so that's good. That's good. So we've set up one thing real quick. And in a competition, this is something that you would try to do. Now, I do want to stress one other thing. As I mentioned with the private key, and I'll show you actually doing this, is let's say that you're in a competition environment. And this is something that happened to us during the very first Cyberforce competition that we ever did, was that there were a whole bunch of private keys on each of these servers. We had no idea. We had never really done anything in cybersecurity before, but they had seeded all of these private keys on all of the servers with the environment. So if I go back to the slides and I go back to, if I go back to our environment. So let's say that they have SSH keys. Let's say that they have stored, let's say private one on the CentOS machine, and the private one allows you to log in to login target. It allows you to log into the Debian machine. And so even if they don't necessarily have an in on the Debian machine, and they're able to get onto the CentOS machine, well, because they have that private key there, they're now able to log in on the Debian machine because they've given themselves those root keys. You always want to be careful with those. They're good in terms of if, like, let's say that you're managing them from like a user machine. So let's say that this was my corporate network environment, and I have a whole bunch of remote workers. And rather than having SSH exposed to the outside world, where you can just brute force and try those login passwords, I'm using that private and public key to better secure myself. You don't want machines within your infrastructure having keys to each other, because that would allow you to quickly pivot between machines. So at least in order to do that, I've given a few commands here. So on the client, we're going to go ahead, and in most cases, this directory already exists. So we already have tilde/.ssh, and I'll show you on the Kali Linux machine. So I'm in root right now, ls-la. We see it's about most of the way down, we see .ssh. So if I head into .ssh, it's already ready to go for me. There's nothing in here because we don't have any. Oh, actually, there is a known host file. But aside from that, there's nothing in there. So in order to actually generate our SSH keys, what we want to go ahead and do is we want to run the following. We just want to say SSH keygen -t RSA. You can set in this case, we've just set the default RSA. You can say you can set the algorithm that you want. So there's different algorithms that you can use. In this case, the default here is the one that we're going to go ahead. So in this case, we first want ID RSA. ID RSA is our private key, and that again is the one that we want to save and safeguard. Make sure no one else gets it. In this case, it is going to ask for a passphrase. So in this case, I'm actually going to set this to 1, 2, 3. Set it to whatever you want. You want this to be secure. You want this to be strong. That is a little bit of the saving grace there. So if somebody does steal your private key, they'll still need to break that passphrase. So as long as you can get and realize that someone has that private key in time and delete the authorized key, you should be okay. But otherwise, you want to make sure that you have a strong passphrase. So in this case, I'm only doing a very weak 1, 2, 3, and it's gone ahead and generated it. It created an ID RSA and an ID RSA. Now all we need to do is transfer it over. The way that I'm going to do that is I'm just going to do a simple Python 3 HTTP server on port 80. All this does is it just creates a very simple web server. This is, you would in production or any kind of other one, this is not how you do this. This is just for convenience right now. But normally, so this is just a quick way. I can go ahead and start an HTTP server on here. I could go ahead and visit it. So for instance, if I go ahead and start Firefox, I can go ahead and pull that up. So let's say that I go to 127.0.0.1, and we see the directory. So this is wide open. Anybody can view this within the network, of course. But if I was just hosting this out and it had a public IP address, they'd be able to see everything. So that's just as a word of caution there. But I'm going to go ahead. I'm just going to use it to make this easier on myself. I'm going to switch over to David. I'm going to go ahead and clear the screen, and I'm going to use wget. My Kali Linux machine is set up to 1.0.5, and then I want ID RSA.pub. I'm going to go ahead and grab http://192.168.0.5 ID RSA.pub. I want that public key. By ls, I see that public key is now. If I go ahead and check, I believe it does not generate the .ssh file. So I'm going to go ahead and say make directory .ssh. We do need to give it a very specific permission set. I believe it is 700 on .ssh for me. And I'm going to go ahead and move ID RSA into .ssh / and actually I do need to create an authorized key. No, that is actually no. Okay, sorry. Okay, I'll reset here. So I need to move this. If there is already, I'll show you in a second what you need to do if there is already an authorized key file. In this case, there is not an authorized key file. And I'm going to push this into .ssh / authorized keys. I believe that's the word. Yes, authorized keys. So I'm going to go ahead and move that in there. If there is already a file called authorized keys, I can use cat. So if I say, and then I'm going to use 2 arrows. The 2 arrows adds onto, it appends to the file. So .ssh / authorized keys. And it'll go ahead and add it to the end. The last thing I need to do is I need to say chmod 600 on .ssh / authorized keys. So that's it. So if I go ahead and I jump over to my Kali Linux machine, and I now try and log in, and if I now try David at .0, it's asking me for my passphrase. In this case, it's ABC. Actually, it's 1, 2, 3. I apologize. And we've logged in. So we're ready to go. So that's just a quick tutorial on how to set up those SSH keys. If I try to log in as administrator, it's denied. So it's important that that authorized keys file was there. If I then move this, if I had a complementary .ssh / authorized keys file in the administrator account in their home directory, and then I use that, I'd be good there. So I'd be able to log in. As I mentioned, I'm going to briefly show how you can abuse this or how you can use this to attack. So let's say that you steal those private keys. So now I'm on my Ubuntu machine. I'm going to go ahead and I'm going to wget that same file. So I'm actually going to go, let's see. Okay, I do have an SSH here. So I'm going to go ahead and I'm going to wget 192.168.0.5 /ID RSA. I don't want the public key. I just want the private key. And then I'm going to go ahead and I'm going to move ID RSA into .ssh /ID RSA. I need to update the permissions on this. So chmod 600 IDS RSA. And now, and actually I'm going to go ahead, I'm going to remove that real quick. And I'm going to, I'll just quickly show you that it's failing to log in. So SSH David at 192.168.0.3. In this case, again, as you can see, permissions denied. But I'm going to go ahead and just re-download that file. Chmod. In this case, I did it in the proper folder this time, so I don't have to move it. And let's go ahead and try logging in now. In this case, as we can see, it's asking me for my passphrase. And now I'm in. And so you wouldn't even necessarily need to attack from the same client machine. You just need the private key. So as you can see here, I've logged in. It was a weak passphrase. You may be able to use something like John the Ripper to actually crack those. I don't remember for sure, but that may be an option. But that's just a brief overview of SSH. So I guess just to recap, what we've done with SSH is we went ahead and we installed SSH with apt install SSH, went ahead and installed the OpenBSD version of it, made sure that it was running. We went ahead and jumped into etc/ssh/sshd_config. If we wanted to, we could change the port. We made it so that public key authentication was the only thing that was allowed. And then we made sure that we couldn't log in with a password. So made sure that people weren't able to do that. And then we went ahead and we generated our own SSH keys on the client. We went ahead and generated those. And then we transferred over the public key to the server. And we were able to log in using that. So that was the main goal there. Hopefully that was helpful. As part of the NCAE Cyber Games, what they ended up doing, especially in the finals, was that they put SSH on multiple machines. So you had to be able to let certain users log in. So you had to have something like this. You had to have you had to use these public private keys. Otherwise, they could either brute force. They had red team users that were just on the machine that they could log into. So that was just a sample there as to why something like that. Next, we're going to talk about FTP. And this one's another really simple one. All these are to actually install them, they're incredibly easy. And that's kind of what I like about it. Again, in this case, we're going to be using VSFTPD. So with file transfer protocol FTP, there's like a bajillion different versions. There's both FileZilla. Then there's a few different ones we have. In this case, VSFTPD. There's a billion different versions of these things out there. In this case, again, it's just an apt. We say apt install VSFTPD. So I'm going to go ahead and jump back over to my machine. I'm going to say apt install VSFTPD. Uh-oh. Oh, I'm not root yet. There we go. So apt install VSFTPD. So I was still in David, so that's fine. Apt install VSFTPD. It's just like SSH. It's very simple. If I wanted to just skip it asking me yes or no, I'll show that in a second here. So in this case, we'll let it go ahead and install. So I could say apt install VSFTPD or -y, and that would automatically skip that. We can go ahead and make sure that it's running. Systemctl, system status, VSFTPD, and it is running. We can also check that with the netstat ANTLPU. And we see here, we now have port 21 has showed up, and now it's listening on port 21. So we have an FTP server. In order to access that, it's fairly simple. It's FTP. I give the user that I want to log in with. It asks me for their password, ABC123. And I can then just read the file. So in this case, here we go. Here's a sample. So let's say that I have FTP access. I could do LSLA. Let's say I want to go into their .ssh directory, and then I can go ahead and grab stuff. Doesn't really do necessarily anything good for me right now for the authorized keys, because maybe I guess if I wanted to lock somebody out, I could do that. But as you'll notice, I can go anywhere I want right now with how this is configured. Now I'm limited in terms of what I can download. So I'm actually gonna pop out here real quick. I'm gonna head to my desktop real quick, just so that I'm putting things in and moving things around. So I'm just gonna create a temp file. So like temp.txt, in this case, yeah. I want to spell that right. Temp.txt. Let's go ahead and log back in. So we're going to log back in, ADC123. And let's say I want to upload it. I believe initially it's actually going to deny me. So in this case, the default, which is good, the default permissions on this is that I can't write. There's no writing permissions anywhere, so I can't upload anything, which is good. Although in a lot of cases, the reason that you have the FTP server is maybe to move new versions of stuff on there. But at the very least, this default configuration where I can't upload anything, that's a good first step. Unfortunately, if I were to go to etc and get, let's say, the password file, as you can see here, it's gone ahead and transferred it. So if I exit, I can see I have this password file. And the password file on its own is not super important. It gives me a list of users. So let's say I wanted to, let's say there was an SSH server on the machine and I wanted to try and brute force it in some capacity. I could go ahead and do that. The bigger target would be the shadow file. So if I do ABC123 and I tried to get etc/shadow, that could be more dangerous because that's the hashes of the user passwords. So I could then attempt to crack those offline. So that's just as a sample there. And again, FTP, fairly straightforward. You just log in. It's with the same credentials that you use to log in normally. I don't know. Let's see. Am I able to log in as root? I think I am. Oh, maybe not. No. Okay. So in this case, this is the one that does not allow me to log in as root. So I can still log in as my administrator. And in this case, I can then get etc shadow because this is a, oh, am I able to run? I don't think I'm able to run sudo. Let's see. Yeah, that doesn't work. So in this case, I'm not root, so I'm not able to get that. But I'm sure there's different other things we can try. So you might be asking, okay, well, how do we actually secure this? And one of the things that we did as part of the cyber games is we allowed, you can actually confine users to their home directory. So we're going to use chroot. So in this case, what chrooting does is it confines you to that home directory, and you're not able to leave it or get out of it, I should say. And what that prevents you from doing is all you see is that it says /, so you think you're in some sort of root directory, but you're not able to go and get something like etc password or etc shadow. So that could be very good from a security standpoint. So all we need to do is we're going to go into etc/vsftpd.conf. So I'm going to go ahead and head on in there, etc/vsftpd.conf. And here we go. So there's kind of similar setup to kind of how SSH was set up. So there's other stuff. Let's see. Is there anything that we need to? You could have, in this case, let's see if anonymous. There we go. So one thing that you do want to keep an eye out for is whether or not this anonymous FTP login is allowed. So an anonymous, and I'll quickly allow it. So we'll go ahead and allow it. With an anonymous login, and it's kind of crazy, but all it is it just allows you to log in without a password. So I hit enter, and I forgot to restart it. That would be an important thing to do. So systemctl restart FTP vs FTPT. So I've restarted it, and I go ahead and jump into it. Exit. I hit enter. So enter is just no password, and I'm in. ILS, PW, where am I? I'm in the root directory. So in this case, I can go ahead and grab stuff. In this case, it's an anonymous user, so there's limited rights, limited rights. But as like a red team might attempt to do is they may set that to yes. They would enable you to write with stuff. In this case, I'm actually going to do that. So in this case, I'm going to go ahead. I'm going to write enable. I'll go ahead and allow somebody to upload something. And you can then enable anonymous uploading and making directories. So you never want that to be enabled. I can't think of a proper business reason or a proper secure reason to ever need to do that. You should have specific users, specific accounts that are able to do certain things. So at least in terms of how we set up the CH root is we're going to go down here and keep going. If we wanted to, we can create a banner. I'll go ahead and leave that. That's kind of funny to me. Welcome to block FTP service. So that's something there. We could deny certain stuff. And here we go. So we have the CH root local user. So give me one sec. So we're going to go ahead and enable that. So we're going to say CH root local user. We're going to go ahead and allow writable CH root. We're going to go ahead and create a user list. So if I scroll down here, I technically could add this here. I could uncomment these as well. The thing with this is that this is a blacklist with this one. So the way that this is going to set it up is it's going to deny the users in that user list. That's okay. So I could say root. So like if I don't want somebody to be able to log in as root, or I don't want somebody to log in as administrators. Personally, I would prefer an allow list. So something that is like I'm setting, okay, these are the only accounts that I want. So because in theory, somebody could create a random new account on the machine and that blacklist would miss that. Or that blacklist would just miss that because it's only blocking root. And in theory, somebody could come along and create a new account and log in through that. So that's just as a note there. So we're going to go ahead and user list enable. Yes. User list file. We're going to go ahead and tell it what file it wants. And then we're going to go ahead and say user list deny equals no. So in this case, we're doing the opposite. We're saying, okay, these are the only, and of course, you want to then go in and you want to protect that file as well, because if somebody can modify it, they could do something malicious with it. But it goes the same way with the blacklist as well. So in this case, I'm going to go ahead and create a user list.blacklist. So etc vsftpd.userlist. I'm going to go ahead and head in there. And I only want David to be able to go in there. So now I go ahead, I run systemctl restart. And I'm going to go ahead vsftpd. And then we'll go ahead and log in and let's see what's going on with that. So let's go ahead and check on what's going on with that. If I try anonymous again, it's going to say denied. Let's go ahead and try the administrator again. That's denied automatically. And then let's try David. So if we try David, it's going to go ahead and ask for it. And you can see our little banner made it. So ABC 1, 2, 3. And in this case, if I were to PWD, it would say /. So before it was PWD and it would say /home/David. But in this case, it's just /. If I do an ls-la, it's .sh. So as you can see, we're in my home directory, but I can't then get to etc/password because because this sees this as the root. I'm not able to do anything. And if you look at what VSFTP actually recommends, is it actually recommends, go back up, it actually recommends creating or blocking writing to that /home. So what I would actually recommend is, I forgot to include it in here. So let me double check. Sorry. I'm going to quickly look it up. VSFTPD. I'm going to actually give them a different root directory. So give me one sec. So we can set it, I'm trying to find the specific name. There we go. It's actually local root. So what we would say is, let's say that we created so ls, we're going to go ahead and switch on over to David real quick. I'm in my home directory. I'm going to create a directory called files or file share. I'm going to go ahead and remove. I'm going to go ahead, as you can see, the file automatically, I can write to it. I'm going to go ahead and chmod a -w. This is removing a permissions on file share. We're going to go back to root. We're going to go ahead and go back into that configuration file, and we will add a conf. So in this case, let's say we would then say local root equals slash, or in this case, slash files, or file share. Oops. Well, file share. I think that's what I called it. We'll see in a minute. Yeah, file share. And let's say, and then we can head on in there. And then I'll just create a directory, pictures, samples. And I'm just to very quickly give everybody all rights to both of those. So this is just like a sample of like a safe or something that we could do if we still wanted this to be used. Uh-oh. We're going to go ahead and restart the service. And this is just something extra. Systemctl restart bsxwd. Uh-oh. I spelled that wrong. There we go. And then now if I were to log in as David. That actually should have been. So I'll double check this at another point. But it looks like this worked yesterday. So clearly I made a mistake in terms of explaining that. But in this case, they actually they said don't. All right. Well, either way, you get the general idea of kind of how that's supposed to work. Let's try that again. Okay, that was a mistake. Oh, you know what? I made a mistake. Okay, that's why. Because I forgot that's why that didn't work. I should have said home/David/ there we go. Now as a note that will drop everybody's local root into that. There we go. It was because /file share doesn't exist. I don't know why I thought. There we go. And now we're gonna go back. And now we see pictures and samples. So now that would be a better configuration. So I apologize on that one. I skipped the little part there, but we were able to get that now. And so let's say I went into pictures. Oops. Oh. And now even though there's nothing in here, but I could put temp.txt up there. It's made it ls and it's there. So that was both SSH and FTP. With SSH, again, we installed it. We looked at the configuration files, we set up SSH keys. But with FTP, we went ahead and installed it, and then we did some CH routing. So we're gonna go ahead and take a break. I would say at a minimum, let's give it about 10 minutes. So we'll come back at around 2:15 at the earliest, I would say. And then I'm gonna go ahead and help troubleshoot that one issue that one of the students was having. So if you're online, I'll go ahead and I'll catch up with you in a few minutes, or just in a second here. But at least here, we're gonna see you all at 2:15. All righty, so we're back, everybody. Hello again, our YouTube friends. So we just wrapped up working through both SSH and FTP. So we went ahead and installed both of those on our systems. And so the only two remaining ones that we have are going to be both HTTP and then DNS. So we're going to set up a very simple website. We're not going to really do anything fancy with it right now. We're just going to install HTTP, get it running, have just a very, very, very simple web page, and then we'll just make sure that it works. And the main reason for that is in order to, well, we could do a few different things, and I'll show you having DNS resolved in something that's not necessarily a website, but at the very least for this infrastructure, we have the DNS that's pointing to our website here. So that's kind of why we set it up, just to kind of mimic something that might be out there in the real world. So in this case, we've decided that we're going to use CentOS for our website. So in this one, all we need to do is do yum install httpd. And so if I go ahead and jump over to our, let's see, jump over to our CentOS for our website here. So I'm going to go ahead and pop that on open. I'm going to go ahead and clear this guy, make sure that we have a nice clean slate that we're working with here with our command line. So I'm going to go ahead and say yum install httpd. We'll go ahead and get that going. It'll go ahead and install some or download some of the stuff, and similar to Ubuntu, it wants us to confirm when we want to go ahead and install something. So it's gone ahead and done it. Similar to Ubuntu, we're still using systemctl. Most, if not everything that we're doing here for this stuff is going to be with systemctl. Now, in this case, unlike with the SSH or the FTP, what you'll notice here is actually it starts dead. So we actually need to start it up for us. So systemctl start HTTPD. By status again, and we see it's running. Now, it's important to note, so if you see something like this, I don't know, it could just be that when it's initially installed, as you can see here, the vendor preset apparently is disabled, and so it doesn't automatically start upon either, I guess, reboot or installation. So if you want to make sure that after you turn off the machine, after it's ready to go, you're going to systemctl enable HTTPD. So what that's going to mean is that if I were to reboot the machine, it's going to go ahead and start, and we're going to go ahead and be. Now, there are two files that we want to go ahead and we want to take a look at here with our website. Is the first one is we're going to go ahead and we're going to check out the var/www directory. In this directory, and specifically inside HTML, is where we can actually host the files for the website. So I'm going to go ahead and say nano. And most of the times, it's going to actually, the indexed HTML is the actual, and of course, I don't know why this does this. There we go. For some reason, Nano doesn't work with that. I don't know why. So if you've never used Nano, or if you've never used Vim before, to go ahead and start adding things, you type the letter I. In this case, it's just a very, very, very simple HTML file. So we give this little header here. And we're not even going to give it like a head or anything like this. We're just going to say, hello world. Nothing fancy. You can say whatever you want with it. Body, and then HTML. So that's all we're going to say. And then, oops, we're going to say right quit. So to get out of the insert, you press escape, and then you say :WQ, exit. So if I go ahead and take a look, and I say ls, we can see index.html here. Now, if I were to run ss antlpu, we see that we are listening on port 80, but with CentOS machines, you actually need to enable the firewall to actually allow it. So before we actually can see this elsewhere, if I were to do, I don't even think wget's on this. So if I do yum install wget, go ahead and install wget real quick. If I go to 127, oops, give me 1 minute. Wget HTTP. For some reason, my caps lock came off on this machine. That 0/1. We see that, oh, now there's two. there's two versions multiplying. We're going to go ahead and remove that file. So as we can see, we can look at it locally. But with the firewall, we still need to set it up where it's allowing it to do it. So we're going to go ahead and use firewall CMD again. So firewall CMD. We're going to say permanent. And just as a refresher, even though we say permanent, doesn't mean that it's acting immediately. We have to reload the firewall. But this will make sure that after a reboot, and in this case, we're going to the public zone. And then we just add a service equals HTTP. Now, the nice thing about this is that if I were to move the port, so let's say I move it from port 80 to like 1234, the firewall is still going to let it through. So that's kind of the nice thing about this. So I say successful. I could add a port, so I could specifically specify port 80 if I wanted to. And then I reload. Just to verify, my IP address is .2. So if I go ahead and head back on over to my Kali Linux machine here in my internal network, I can go ahead and head on out to 192.168.0.2, and we see our lovely hello. So that's at least, and then there's a whole bunch of there's HTML. You could learn how to do some PHP stuff, JavaScript, and that I'm not very familiar too much. I just know how to do this pretty much. But this is a very simple website. And again, we're mainly doing this so that we can point to it with our DNS records. We are going to do a little bit with it in terms of incident response in a couple of weeks, but this is just kind of mostly. If you want to look at where the configurations are hosted, so if I go to vim etc/httpd dot slash httpd dot or slash okay, I'll start over there. So I go vim etc httpd /conf. I believe it's actually conf.d. Let me double check here. No, http.conf. httpd/conf. There we go. Okay. I'm gonna step through the files there. So I'm gonna go to etc/atpd. We see conf. Then we can vim httpd.conf. There we go. So there we go. So this is the configuration file. We can find a few different things. For instance, we could change the port that we're listening on here. We can change the IP address, kind of similar to what I was talking about earlier. It may have like an interface setting, but if you have two different interfaces, you can go ahead and set the specific IP address that you want it to listen on. We can find some other stuff in here. So for instance, this will by default, and we'll see it here in a second here, this will block me from viewing any pretty much this sets a rule to block all directories on the computer. So it says require all denied on directory /. So this says, hey, don't check out other directories. We do override that down here by saying var/www.html. So if I were to, and I'll go back and I'll show this, but if I were to create a additional directory or anything like that, I could then see that directory on the website. So here we see, hey, relax that rule, and we can require, or we can allow people to view it. And that prevents us from doing something like a path traversal. So let's say if I were to head back out to my Kali Linux machine, and in the search bar, there's all sorts of different types. If I were to just add all these like back steps here, and then I said etc password, in theory, I could try and go there, but in this case, it automatically truncates it for me. It's very nice in that regard. But otherwise, in some attacks, they'd be able to move over and try and find stuff in directories that they're not supposed to. So that's just as a note there. I'll show you real quick, just kind of creating a quick clip. I'm going to go to var www/html. I'm going to create a pictures. I don't know why I like the pictures or Bootcamp. And if I head on over to the website now and I say /bootcamp, it is now a directory. So kind of similar to when I ran the python-m. So if I do exit python 3-m, it's very similar in concept to that as to how that. So that's really all I've got for now on the HTTP. I didn't want to go too in depth with this. I didn't want to go too much into HTML. I just wanted to show you installing HTTP, where you need to go. It's going to be var www.html, and then a few different things, at least in terms of the configuration. And then the last thing that we have here is DNS, or domain name servers, or server service. I've heard it both ways, but we're setting this up on Debian. And the general idea for DNS is we use this every day. And the way that this works is essentially, it's how we figure out what the IP addresses of the servers that are hosting our websites. So you're going to ask your local DNS server, hey, I want to go to example.com. And he's going to try and communicate with the root and be like, okay, hey, where's example.com? And he's going to say, okay, well, I don't know where exactly that is, but I do know where the .com top level domain is. So then you talk the top level DNS. So it's going to go ahead and it's saying, okay, hey, where is example.com? And then he's going to say, okay, here is the DNS that's serving example.com. And then we finally get the IP address that we need. We can also do a reverse lookup. So that's, I think, a forward lookup is you have the domain name that you're looking for, and it's going to give you the IP address. If you know the IP address for some reason, and you want to figure out what the domain name is, you can do a reverse lookup to figure out what the domain name of the service is, or what of that server is. So all we need to do is we're going to do this on the Debian server. So we're going to use apt to install bind9 utils, and bind9-doc. So I'm going to go ahead and find my Debian. So here we go. Here's the Debian machine. I'm going to go ahead and blow this up. We go ahead and clear this out. Head back to home. Apt install bind9. Bind9. Let's see, just double check what do we need. Bind9 utils and bind9-doc. I believe bind9 is the package that has the templates that we're going to be using today. So it's going to go ahead and install that for us. And here we go. It's almost done. There we go. So if I go ahead and do systemctl status bind9, we see that it's running. Good. All right. The first thing that we're going to do is we're actually going to say that we exclusively want to do this over IPv4. We never set an IPv6 address, so we want to specify that we are doing this over IPv4. So we're going to go to etc/default/name. It's going to look like this. And actually, I'm going to do this in Nano. So just in case there's people who are not as familiar with Vim. So I'm going to do Nano etc default/named. We see resolves.conf, no. And then rather than bind, you're going to add a -full. So that's all you need to do. You go into etc default/named and then update that file. So we're going to go and update that. Next, we're going to go ahead and set our configurations for the bind9 server. So we're going to head into etc/bind-named.conf.options. So etc bind-named.conf.options. And we see this file. At the top of the file, we need to, and actually give me 1 second here. We need to add trusted, and then we give the IP addresses. Give me 1 sec. I need to verify on my slides, and I will update the slides after this. I forgot to add exactly how to add that. So give me 1 second here while I verify. And I will get back to you all in 1 second. There we go. And that's actually, I did this in. So it's going to be ACL, access control list. So this is just telling us who can actually access it. Now, if you want to, you can just use the CIDR address. So for instance, I could say 192.168.0.0/24. And that would be it. So I could say that. So I could say 192.168.0.0/24, and that would affect my entire subnet, and anybody in the network could do it. Alternatively, if I wanted to, I could specify given IP addresses. So I could say, okay, I only want this is the signed website. This is the Ubuntu workstation. This is the DNS server, Debian DNS. And then this is my Kali Linux. I could say that. I could do that. If I wanted to, I could also add in the router. And this would be effectively doing the same thing. Is the same as the 192.168.0.0/24. It's effectively the same. So I want to make sure that we list who's allowed to use it. And then we're going to go ahead and head on into options. And we're going to go ahead and add in a few things. So we want to allow recursion. I don't remember exactly what the recursion does for us. If I had to say most likely, I'm not going to guess there. I don't know for sure. I don't want to mislead. I don't remember exactly what that does. So I apologize for that. But we want to enable that. We want to go ahead and allow it within our trusted domain. And be careful here. Sometimes within this, DNS, unfortunately, Bind9 is very picky about spacing and how everything is set up. So if you see it here, you see, okay, I went ahead and added recursion, yes. Then within these brackets here, I added a space. I believe it'll still work if you don't put that space there, but just be careful. In other parts of the Bind9 stuff, it's going to be very picky about it. We're going to go ahead and set the IP address that we want to listen on. In this case, it's 192.168.0.4. And then we're going to allow transfer. We are actually not going to allow transfer. We're going to allow it to none. So we're not going to allow anybody to do any kind of zone transfer. And then we're going to go ahead and add forwarders. What these forwarders are is just if somebody else is redirecting to us, is that if I need to find something at a higher level, it knows who to try and contact. So I'm going to go ahead and add the Google one, 8.8.8. I think it's Google. And it's going to go ahead and add. So this is within etc/named./conf.options. And this is our options that we need. So that's it for there. So we're going to go ahead and write out for this. I'm going to go ahead and exit it. Next, we're going to go ahead and add our zoning. So in this case, we want to say etc/bind/name.conf.local. And now we're going to go ahead and add our zones. So there's two zones. There's a forward zone and a reverse zone. The forward zone is going to match the IP address to the domain name, or it's going to basically, if you give somebody the domain, it'll give you the IP address. And the reverse lookup is going to, if you give it the IP address, it'll give you the domain name. So if I go ahead and add this in, it's going to be zone. In this case, the domain that I'm going to go ahead and add is called bootcamp.ilcyberhawks.com. It's a primary zone here. And the file that lists the configuration for it is going to be located in etc bind zones db.bootcamp.il, oh, spelled that wrong, .ilcyberhawks.com. So that's it for that one. And then the reverse is a little weird in terms of the writing. You take the reverse of the IP address, or the subnet, I should say. So in this case, we have the subnet in this case is a 192.168.0.0/24. So with a 24, the only octet that's left is the last one. And so the reverse is going to be 0.168.192. So that's kind of why you'll see it in a sec, why it looks a little funky. So like you'd modify this if it was a 10.10.10.10, so 10.10.10.0/24 network. Your reverse would be 10.10.10. It's not the best example because it's all tens, but that's just an example there. So in this case, it's going to be 0.168.192.inaddr.arpa. It's another primary one. And the file, very similar structure, etc/bind/zones db.0.168.192. That's it. So there we go with the setup there. So now we actually need to create these two files. So give me one sec. Yeah. So we're going to go ahead. I'll leave that up for another second in case people are typing it out. So now we're going to go ahead and write it, and that's it. Now, I believe because we downloaded bind9-doc, I believe that's the proper one, we get these nice pre-made configuration files. So we're going to go ahead and copy etc/bind/db.local to etc/bind/zones. Actually, I may have to create zones. Give me one second. Let's check. So etc/bind is zones here. No, so we got to make directory. We got to make zones real quick. So we've made zones. I don't remember. We'll see in a second here if I need to change the permissions on that. I don't think I do, but we might need to. we're going to go ahead and copy etc/bind/db.local. And we're going to go ahead and throw it in zones db.bootcamp.ilcyberhawks.com. So we're moving the configuration file. That's the one that they gave us by default, the temporary one. And we're going to go ahead and create it under the domain that we want. So we're going to go ahead and head on in there. Okay, so this is kind of where it gets very picky. So if I go ahead and start here, so I'm going to replace localhost with my domain. So bootcamp.ilcyberhawks.com. Make sure that that dot at the end stays there. I'm going to update this. I believe you can keep it as root. I'm going to say admin.bootcamp.ilcyberhawks.com. Let's keep that period there. You need to update this serial number every time that you make a change and then reboot the service. So in this case, I've made a change. I've updated this to 3. And then we're actually going to wipe all these 4 out. So in this one, we're going to go ahead and add what's known as an NS record. So in NS, and the NS record just points to the name servers. So in this case, name servers, the semicolon goes ahead and comments out after everything after it. So I'm okay with saying this. So this is our NS records. So in this case, our NS1, which is our name server 1. I could have multiple name servers. So I could have NS2, NS3. I could have multiple name servers within my infrastructure. NS1.bootcamp.ilcyberhawks.com. And actually, I do need to have that period. Then I'm going to have name servers. And we're going to have our A records, which is our name server, sorry, our name server A record. So in this case, we're going to say ns1.bootcamp.ilcyberhawks.com. And we need the period. The A record just points to, it gives the, it associates that this IP address with that domain name. So it's 192.168.0.4. And now I want my A records, which are just going to assign my internals. So for instance, I have web.bootcamp.ilcyberhawks.com. Need the period. INDES-A. Then we're going to go ahead and give our IP address. So in this case, my sent website is 0.2, and then my workstation is .3. So work.bootcamp.ilcyberhawks.com, INA 192.168.0. There's a red guy here. I don't know why it's here. So there we go. Okay, that's fine. Okay. So that's what your forward zone should look like. So I'll leave that on the screen real quick. I may have made a typing. I'm going to check for spelling here. Spelling can really mess things up. So I'm just double checking for spelling. Everything looks okay at first glance to me. I'm going to go ahead and write this out, and then let's go ahead and move on over to the reverse lookup. So if I go ahead and copy db.127 to etc/bind/zones/db.0.168.192, that weird backup, the weird backup, the backwards IP address, etc/bind/zones/db.0.168. Same setup up here. So it's still going to be bootcamp.ilcyberhawks.com. And of course, you could have like a different link. So I could have, if I wanted to, I could have said ilcyberhawks.com. I guess you could even just have a single, you could make up a new base directory, a top level directory. So instead of like .com, you could say like .cyberhawks or something like that. You're welcome to try that. And so forth. So we're going to go ahead, follow the same setup here. Going to go ahead and update this to 2 now. And we're going to go ahead and wipe these out because we don't need these anymore. Similarly, this is the NS records for my name servers in ns1.bootcamp.ilcyberhawks.com. Need the period. And actually, I will go back and double check to make sure I had periods all over the other guy. And then this is my pointer records. Pointer records resolve the IP address to the domain name. And it's going to start a little weird. So before we had the domain name first, Now we're going to start with the IP. So at the top, if we consider what we labeled the file as, it was 0.168.168.192. So what you're going to do, cancel. What we're going to do is we're going to kind of build this up. So the 192.168.0.4 is my pointer for ns1.bootcamp.ilcyberhawks.com. But in order to put that in, we actually only use the 4 because of the way that it's typed. So now the one that is IP address of 2 is my web. So web.bootcamp. And then 3 is my workstation. I couldn't tell you why they did it like this, but they just did it. So I'll leave this up on the screen real quick in case you're trying to type along. But that's how you set up that DNS. So I'll go ahead and I'm looking for spelling. Spelling looks good to me. So in order to verify, there's a few different options. We could just restart the service and pray, cross our fingers and pray and hope that it's all good. But there's actually 2 tools. We can use name.checkconf. So in this case, there's an issue with, let's see, named, aha. So there's an issue with this, and that's where name.checkconf comes into play, is we can check to make sure in this file that we've done this properly. So we have to go back to name.conf.options. And as we see here, let me just double check against my source real quick. Make sure that that looks good. Ah, here's why. I was not able to, and that's on me. I should not have left these out on the open here. I should have used either a // or a pound sign. So I apologize for that. So that's why that was kind of complaining and yelling at me. So now if we go back, sorry about that. Now if I go back and I do name checkconf again, now it's clear. We're good. It's happy, apparently. So that's good to know. And then we can also do named check zone. And we can check to make sure that the zone or the domain that we've put, so in this case, bootcamp.ilcyberhawks.com, you're basically just checking to make sure that that domain, and in this case, we get an okay. So we're happy. We can also do the same thing with our reverse. Actually, I don't remember what the reverse name is. Let me look it up real quick. And we should be good to go in about a second. Let's see. There we go. Here, yes. Dot in addr.arpa. So just like what it was in the options, no, in the zones file. I apologize. etc/bind/zones/db.0. Right, and that one gives us okay. So from everything that I'm being told by the computer here is that everything is good to go. So we can go ahead and reboot bind9. No errors. We can go ahead and verify it with bind9. It seems to be good. It's having an issue with some sort of something trusted, but it sounds like everything is at least running. So I'm going to go ahead and accept that, and we will be happy about it. So we'll leave that here. If I wanted to actually double check to make sure everything's good, we're going to go ahead and update etc/resolve.conf. We're going to go ahead and rather than looking at 1.1.1.1 or 8.8.8.8, we're going to go ahead and point it to ourselves. In this case, it is .4. And we can go ahead and ping, let's say, web.bootcamp.ilcyberhawks.com. And it is automatically going to resolve to that. I believe you're still able to ping Google. And in fact, you cannot. So I apologize for that. So I actually still need to have this other name server here. So I need to have name server 8.8.8.8. So in this case, Now if I ping Google, it fails. Okay, something. Oh no, they had an IP address. I don't know what's going on here. It did figure out the IP address. I'll have to double check to make sure something weird isn't going on with that. But at the very least, we're able to ping internally. We're able to see, okay, I said that the website was web.bootcamp.il CyberHawks, and we are happy and good to go. So if I go back over to my, let's say my Kali Linux machine, and I jump over to Kali Linux, I do the same thing, etcresolve.conf. I go ahead and I say, rather than 1.1.1.1, I'll actually leave 1.1.1.1. No, actually, I'll put it second. And then I'll add 1.1.1.1 afterwards. Oops. Permission denied, I need to be root, that's why. There we go, made it. Go ahead and add that. And now I can not only ping, but I can actually visit, rather than using that IP address that I used before of just adding in 192.168.0.2, I can say web.bootcamp.ilcyberhawks.com. And actually, for this one, I may need to say, let's, sometimes the Kali Linux can be a little bit weird. Let's see, can I ping it? We're gonna try this real quick. Oh, you know what? So sometimes, and let's see. There we go. So that needed to be the first. That needed to be the first thing. So there we go. If I wanted to, what I could go ahead and do is I could see I could do FTP David at work.bootcamp.ilcyberhawks.com. And in this case, it works the same way. So I could do. Give me 1 second. Put the password in. So now I'm in. I could do the SSH David at work.bootcamp.ilcyberhawks.com. In this case, I know I think my password's 123, and I'm able to log in. So I'm able to then use the domain name instead of using the full. I could use NSLookup to verify here as well. So NSLookup, bootcamp, or NS1. So like if I wanted to look at the name server, bootcamp.ilcyberhawks.com, and it would give me the IP address that I'm looking for. I could also do the reserve. I could do the reverse. So I could say, I know the IP address is this IP address. I will then get back the DNS name. So that's pretty much it. I don't have anything else, at least in terms of next week. And so this is most of it. I'll update this with, I think, the full picture from the other thing. But you can verify again with checkconf and then with NSLookup. At least in terms of for next session, we're going to be using the platform called TryHackMe. The initial sign up is free, and so there's actually quite a few rooms that are free as part of the base TryHackMe package. So I'll go ahead and it's just at tryhackme.com. You had it out there. So Darnell 3. Sorry, I don't know why I verbalized that, but I can go ahead and log in. Go ahead and log in here. You get a dashboard, and there's a whole bunch of different pathways that you can follow. So next week on, I don't remember, I want to say it's Wednesday, you can learn, we'll be using this platform rather than setting up a whole bunch of vulnerable machines inside our environment. So that way it's a little bit safer on that. So make sure if you do want to follow along that you at least sign up for an account. I'll try my best to find ones that don't require a subscription. If you have a subscription, that'll make it a little bit easier. Because then, or like if you have a subscription, you get access to all of the rooms in the system, and then you also get more access to different tools inside of it. So that's just as a note for next week ahead of the next session. So alrighty, well, thank you so much, everybody, and that'll be it for this session.